Hello interwebs, welcome to Let's Fix Computers. I am maybe fixing an ATX motherboard today. This is an Asus X570 Strix X570E Gaming. And this is one of my favorite AM4 motherboards. I have two in the shop, X570-F motherboards. And the X570E is basically the Wi-Fi version of it. And you can tell because it's got Wi-Fi 6E on it, which is why it's the E designator. I don't know if there are any other differences between this and the F. This was like a second revision or something like that, I think. But the boards are extremely similar. Anyway, so this one is a mail-in repair, and the customer removed their graphics card and dinked the board and damaged it, and now it won't run. So as soon as I took it out the box, immediately I went, I'm going to look there, because what I can tell you what we're going to find is they couldn't get their hand in there to dink the switch open, and so what they did, which I have done plenty of times myself, is they got a screwdriver and they went with a screwdriver, and as soon as that opens they went whoop off onto the board. And I can tell you for free, because I've already had a look at this thing, that's exactly what happened. So let's swing in with the microscope and we can have a look, and I'll show you what we're up against. Alright, so here's the top of the PCI Express slot here. There's the catch, and there's the bit that the screwdriver hit. So we've got a couple of smashed components here. We've got a capacitor, which the side is smashed. We've got something here that's gone entirely. You can see from the shape of the pads that something was here and is now gone. This guy's been nicked on the side. This guy, the end, has been smashed. This guy's been nicked, but he might be okay. That might just be a graze. And then we've got a scuff mark here. But if you have a look at these pads, and this pad, see how they're rounded? They're just round pillows. These are no stuff pads. So there wasn't a component here. That has been scuffed. However, I can say with reasonable certainty that there was not a component there. So we're not missing anything. So the damage is here, 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 and here. So what is this area of the board? What is this doing? Well, that's going to be difficult to tell, because motherboards are a little... ATX motherboards are somewhat esoteric. However, I've done a little bit of looking up online ahead of recording this video as a viability check, and I think I can explain what I think it's going to be. So let's come out of the microscope. Okay, I need to pause for a moment here to cover a massive cut in the video that I'm about to make. What I did next was I looked around for a schematic for this motherboard, and I had found a schematic for the X570-I, which is the ITX version of the board. And given that that was just the smaller version of this motherboard, I was really hoping that that was going to have enough information on it for me to be able to show what this section of the board was doing and get actual values for these components. But long and short of it is, when I looked it all up, there was really no useful information in the schematic at all. Like, it wasn't just that it was incorrect, there was just nothing of value there that actually explained anything to me at all. So instead we're going to skip past that section, and I'm going to steal a different motherboard and use that as a reference. So that leaves me with another choice then. I mentioned that I've got another two X570F motherboards in my shop. The other alternative is I just get one of those, remove these missing components from them, and measure them. Before we do that though, I'm just going to quickly check if we've got any actual short circuits here as well. Just to see what information I can garner without having to take stuff apart. So that looks like that's shorting across there. So I'm just going to check these two pads and see if they're shorted together. And yeah, they are. So if I just brush that aside, they're still shorted together. Okay, we don't know if they're supposed to be or not. These could both be grounds. So let's check that. I'll put my black probe on a screw hole and I'll just check there. That's ground. The other side is not ground. And that is also not ground. So this is probably a pull-down resistor in that case. And these are just... But then if they were both ground, I'm surprised they're not joined together. So that's difficult to judge. So basically my concern is that there is something else downstream that has been damaged by these two being shorted together. And we'll kind of never know. But, that's fine. What about these resistors? Let's just measure these in circuit and just see what we get. Because if I get plausible numbers, maybe it's okay. That's bang on 500. So I think it's reasonable to assume that that's a 500 ohm resistor and it's within spec. Okay, what about this guy? This is reading open and is visibly in pretty poor shape. So that guy's busted. That slowly crept up to 4 ohms. That doesn't sound like a valid reading. What about this? Same deal. That's kind of suspicious. I think what we're going to have to do is get a donor board, very carefully desolder this entire column here, and measure all of them. So kind of sucks. I don't want to risk damaging one of my own boards, but it's only 1, 2, 3. It's only 6 parts there, and if I go slow and steady, there's no reason to damage that. Okay, let's do it. Okay, so I've just pulled an X570-F out of one of my demo PCs here. So we've got a more or less identical board to compare to here. So as I mentioned, the Dash E has a few extra pieces. It's got Wi-Fi. It also has a postcode readout down the bottom here, and it also has dual Ethernet ports. So there are a couple of small differences across the board. There are 1 or 2 things here and there that are slightly different, but the fundamental operation of the board is the same. We've also got a bit of extra metalwork on the Dash E. This is non-functional. This is just for show, this bit. However, what we care about is if I remove the PCH covers and the SSD heat sinks, we will find that the area here on both boards is actually identical, and that's what we really care about, because now I've got a reference here. So we're going to go under the microscope of the Dash F, and we're going to try and measure out a couple of those resistors just to see if I can avoid having to take it all off the board. However, also I think we're going to have to remove some components because there are some things that you just simply cannot measure in circuit. For example, capacitors. If you try and measure a capacitor in circuit, you're going to get the capacitance of everything that it is also connected to. So you're just not going to get a real number out of that. So here's the X570F, and you can see we've got that familiar section, except on this one it's not busted up. You can also see the confirmation that these pads are indeed no stuffed, so we don't need to worry about what's here. So what we want to do is measure as much of these as possible. So firstly, we've got a 472 there. So that is 47 and 2 zeros. So that's 4.7K. So let's just measure and confirm that. This one's an easy one because it's big enough to actually have a value written on it. There we go, 464, close enough. So that is a capacitor again, I think. I'm just going to quickly, I'll put the multimeter on that, but I'm 99% certain that is a tiny little capacitor, so we're going to get nonsense out of that. Yeah, I don't know what that is. Right, what about this guy? That's short, that's interesting. I did just scratch the top of that, but I can't see a world where that's just broken it. Could be a 0 ohm link. Alright. See, the problem is that one we're going to have to take off the board to confirm it. because I want to be damn sure if that's a 0 ohm link or not. All right, what about this guy? 500 ohms. I think we had a 500 on the other one. And 5K, that also looks plausible. Right. So we've got a 4.7K, we've got a 500, and we've got a 5K, and we've got maybe a 0 ohm resistor. Sometimes 0 ohm resistors just get used as a poor man's fuse, basically. Sometimes they use just to jump over traces on the board, but like this isn't jumping over anything, so I'm not quite sure what purpose that serves, but it's reading 0, so whatever, I guess. So what I'm going to do now is I'm going to put a little bit of flux on the board, and I'm just going to twist a couple of these components around so they're out of circuit, and then I can measure them. Wow, what is this flux application? Nah, that'll do. Because we also need to make sure that we catch, we need to figure out what those capacitors are, and those have to be out of circuit. So this guy we want to twist because it says it's 0 ohms and I don't believe it. Switching tweezers and coming in with a bit more air. Come on, dude. Don't fight me. Okay, there we go. Things were starting to get a little bit toasty down there. Right, so this guy confirmed is just a 0 ohm link. Okay. And so now we want to measure these two little capacitors here. So let's go to capacitance mode on the multimeter. Oh, I forgot to get this guy at the top. Heck, I'm going to move that while the board is still warm. Alright, this tiny guy, that's a 100 nanofarad capacitor. This tiny guy is a 1 nanofarad. And this guy is also 100 nano. Right, additionally, this pad is reading low resistance to ground. And so's this one. So that tallies with what we saw on the other board. These guys are both low resistance to ground. So they might be ground pads, or they might just be going through something. They might just have a low resistance path. So one more time, let's just compare those results with what we got down here, and then I know finally exactly what parts I need to replace. So you were supposed to be a 0 ohm link. See, that one's reading 500 ohms, which is oddly specific. And that one is open. So this is the problem with reading in circuit. We don't know what other path we're finding here. That one's giving a nonsense reading. Okay, I think we're going to windscreen wiper this, which means I'm just going to take all of them off and replace all of them. So I will need to find the parts from some donor boards because I don't have these exact parts on hand. But yeah, what we're going to do, I'm just going to windscreen wiper this off the board. We have measurements from a known good board, and we'll just find the replacement parts. So let's put down a crap ton of flux there, and we're just going to take the whole lot off the board. Now some fresh solder and wick. Okay, now I've got to track down replacement parts, so I'm going to go and raid my donor boards. I've got quite a couple of spare MacBook boards that are all dead in one way or another, and they are a great resource for finding small components like this because the MacBook logic boards are incredibly well documented. So I can just search the schematics for 100 nanofarad, 4.7K, and stuff like that, and find random resistors and capacitors on those boards that I can steal and put on this one. So I will go and do that, and I'll be back in a moment. So let's touch some fresh solder onto all of those pads. And let's start transferring components in. Now, I can already see that some of the components I've picked off are the wrong size, but hopefully we'll make this work. Cha. Alright, let's put some alcohol on there and to Q-tip that down, and hopefully it will look a little bit less jank. That's some components on the board. They're reasonably straight. So the one that I've got that I'm slightly worried about is this capacitor in the middle here. I've put an oversized capacitor on, and I'm not actually certain if it's contacting properly. I might just see if I can peek that, actually. Maybe. Let's see if it works. And then, as you can see, that 0 ohm link, I've just solder blobbed that. Okay, I'm going to take this board, and I'm going to drop it into the chassis that I took my board out of as a test bench, and see if it posts. Yeah, I can drag that computer over here. So I'll get that in, and we'll do a post test, and we'll see if I am WinRAR. Previously, we could not get to BIOS, so if we just simply get a post and get to BIOS, then we win. So, see you guys in a moment. Right, I think I've got enough here to do a power on test. So I'm going to hit the button. Here goes nothing. Right, that looks good. Postcode readout is doing stuff. Now, apparently it was getting to 00 last time. Looks like we've got a boot. I'm just waiting to see if we get output from the graphics card. And there we go. There's a boot screen, everyone. We win. So, this board is all good to go. So, I'll take it out of this I'll take it out of this chassis and just put all the covers back on and stuff like that. And that will go back to the customer. And then I've just got to put a few bits back onto my board to get that one ready to go again. So it'd be interesting to know if anyone knows actually what that section of the board is doing. I'd be very interested to know, because fun fact, this isn't the first time I've encountered this. Not this X5, not this Strix, but another Strix I've got in one of my other demo PCs also had damage to that section when I bought it. I got it cheap because it was damaged. And that one, the topmost capacitor was chipped, and I think I just took that off the board and it just still worked. So I got away with that. However, the point is, this kind of damage is common, and I'm very interested to know what that circuit does, because it's the spot that everyone hits with a screwdriver when they try and screwdriver their graphics card out. So anyway, that's where I'm going to leave you guys for now. So thank you very much for watching. I hope you guys found that kind of interesting, and I'll see you in the next video. Bye.